Hello, welcome to my channel. Now, what we're going to do now to get it faster is this algorithm called alpha beta. Pardon. If the moves are in a good order, you get more cutoffs. So what that means is if at the moment when we play the game, it just does it in a certain order. However, if we was making the best move, like for instance here, if that was the first move searched and it was the best one, then you'd get a lot of cutoffs. So we have to do less searching. So where we can speed it up is make the best moves get played first and make the worst ones get played second or third or whatever. And then we'd get more cutoffs. So that thing here where I said it cuts all of them off and it cuts them off, can you see? That certain criteria have to be met. If that 7 was over here, then there wouldn't have been a cutoff here. But because we searched certain moves, an example, these moves are worse. And because they are worse, we got to cut off all of this branch. So with alpha beta, all you have to do is sort the moves in a certain order, and then you will get a better game. Now, what I was thinking of doing is the evaluation function, which is this, where it says return 0. Like for here, if it's a win, I alter it by putting this state in just to make it fight to the death. Okay. Now, what I was thinking of doing is putting something in here to say, okay, if you think the position is a draw, add an extra score for the middle score. If the piece is in the middle, add some extra score to it so that you can get the computer to start playing in the middle more. Okay, and that would work. But a pure way to do it is, because if you notice when I play the game, it goes like this is how the game tends to go, and then I go like that, and as you can see from this position, and then it goes there, and then I go here. From this position, can you see that? I've got 4 and he's got 4, but mine are in the center. That means they can make 4 in the, there's more opportunities to make 4 in the line, whereas these 3 here are dead. Can you see, like, on that side, there's nothing here, so you can't make 4 in the line here. You can't make 4 in the line over here. You can only make it here, and I'm blocking these 2 here. And I'm blocking that down, so therefore there's less opportunities for this to make, and whereas with me, I can make 4 in the line there, and that's why I'm winning. That's why I keep winning. Or this is my strategy. I take the center one because it's searching the move order. It searches these first. Because when it gets the moves, when it's looking at this position to say get the moves, it will get that first, that. And as you can see, that is at the edge. That is you could say that's the worst move. That's the second worst move. So if we change the order that it gets the move to make it get that first, then that, in theory, because we're getting better moves, because we're getting better moves, we should get more cutoffs. And that should hence speed up the game. So it creates a speed increase. Okay? So what I'm going to now do is I'm going to put some code in so that we won't be able to beat the code. We're going to be hard for us to win now because it's going to start playing in the center squares. We can still beat it, but it's not going to be easy, okay? Because it's going to also speed up as well. Okay, so this is just going to be move ordering, so it's not going to alter anything. It's going to. The good thing about this is an optimization, but it's going to be exactly the same as Minimax. For instance, if we had an infinite processor and we said, find the best move in this position, Minimax, and this will come up with the both with. If there was a force win, they'll both find it. So for instance, if we said, look at this position to a depth of 20, if there was a force win in 19 moves, Min-Max and this will find the exact answer. Okay, but the only difference with this is this will go for the middle moves more than Minimax. Min-Max will still go for these moves. Okay? Because with Minimax, remember there's no cutoff, so for us, it wouldn't make sense doing it. Really, it probably might improve Minimax if you don't ordering on it, but there wouldn't be any cutoffs. So I'm gonna do a bit of it here. I'm just gonna put some. I'm not gonna put any code. I'm just going to code. Now what I want to do is I want to replace this right there. I want to replace film is. This is the one I want to replace. So what I need is I'm gonna get what it is. Sometimes in coding, you want to change something and you don't want to break anything. Like look at this move list here. That's used down here. And what it is, if I mess about with it, I'm going to miss something and I'm going to create a bug. So what I'm going to do is I'm going to modify it without and minimize my chance of creating a bug. So what I'm going to do is I'm going to create a new variable and I'm going to call it pre-move list. And what I'm going to actually do with it is okay, look at that one. Let's just create an extra space between them. Wherever it says move list, I'm going to replace it with pre-move list. So that will get us the pre-move list. And then now I can do move list equals and it's not going to work now because I'm done. So therefore, now what I have to do is create that function and put some code in it so it does actually do something. But I'm not going to put any code in it to do anything yet because I haven't worked it out yet. So I'm just going to create it. It's going to take an array. And that's going to be it. Now I'm going to talk about how we're going to do that code. Now if I said get all the moves, it will get me the... What would it do? It will get me all of these. In fact, it wouldn't get me all of these, but I'm going to copy all of these. It will get me all of them, but it will get me 56, 56, and 57. Okay, so that's what I think. 46, 57, 56. Oops. So that's what it will get me. If I was at this position and I got on the code Who's that again? So it comes to here, fill move list, and I'm not sure if you remember what this code does. This code actually gets the legal moves so that you can try them. So it will say, get all legal moves, and then we'll get that. And normally what happens is it feeds them in. So it would always do 46 first, 56, 57, 49. So it's doing. So we really want it to do 49 first, then 57, then 59, then 56, then 60, then 46. That's the order we want. So we have to have a way of ordering them. So what we have to do is, if we look at the board width, we've got a function, we've got a constant called board WW, and that's equal to 9, and we got one called board it's called board W, and that's equal to 7. So what we need to do is, for us to get the middle, first thing we have to do is change all of these numbers into modular board WW, i.e. the remainder when divided by 9. So if I divide 46 by 9, I get 1. If I divide 56 by 9, the remainders are going to be them. Okay? 1, 2. So we've got to order. So what I'm going to do is now what I have to do is work out how to sort them out. So once I've got the modular of them, how would I sort them? What I'd have to do is I get this number here, divide it by 2, and then hit the ceiling. What that means is this is going to be a fraction like 3.5. That means round it up. So even if it was 3.00001, we round it up to 4. So what I'll do is I'll get the ceiling, and that will give me 8. I mean, I divide it by 2, and then I hit the ceiling, and that will give me 4, which is the middle number. Okay? So what I'll then do is take that middle number and take away 4 from everything in here. So I'll get 0, I'll get -1, -2, and I'll get -3. And I'll get 1, 2, and 3. Okay, so that's what I've done. I've taken that number, divided it by 2, and then do math ceiling. So I get the ceiling, I get 4. Everything in this array, I'll take 4 away from it. And then I get these numbers here. And then what I now do with these numbers is, I get the absolute value of them, which means if it's a plus, I get rid of the plus. And if it's a plus, it stays the same. If it's a minus, I get rid of it. It's equivalent to squaring the number and then taking the square root of it. Or it's a function that times it by -1 if it's less than 0, or if it's more than 0, it doesn't times it by -1. Okay? So that's what I'm going to be left with. And all I have to do with these now is sort them in order. So what I get is 0, 1, 1, 2, 2, 3, 3, and then that will be it. So what we've done here, that's a sort. So we need to do a sort here. Okay? The rest of it, all of it can be done in a sort. Okay, we can do a sort. Okay, so it's a bit complicated, but in a sense, it is a sort. So best thing you do is you go to this Java developer site and you look up sort, and you see if it can help you. Like, that's what I first did. I looked at it. I used a sort. I looked at sort, looked through it, and then I found this, and that would be able to. So you can do a function to compare it. It says A is less than B by some ordering criteria. So our ordering criteria would be math ceiling, take that number, get that number, find the ceiling of it, take 4 away from it, find the absolute value, and then sort by that. So that will be our criteria to sort. So what I'm going to do is, I'm going to now create the function. But I'm going to paste it in and talk about it. Right, this, I'm getting the board, I'm getting these variables from this game. It's the D constructor. I'm just getting these variables. Now, that variable, that number, we do math ceiling, the board divided by 2. I just call it magic. And then this is where we do the array sort. And as you can see, look at that code there. And look at this. Blob, blob, blob. Okay, so I think so it's that function, and then you put the, and what you do is you feed the function in like there, like here. That's what I did. Okay. So what's that's doing exactly what we said it's going to do. It gets, so what it does the modular of the board WW. That's how it's going to, this is the criteria it's going to sort by. Modular of board WW, that's going to be A, and the other one's going to be B. So it's going to, that's the first step. If I can bring them both up, that's the first step, taking the modular of everything. The next step is taking the absolute value, which is turning them into pluses, all of them into pluses. And then you do this. Our criteria for less than is this. So when we do this criteria, we're able to sort them. And what we get returned is them sorted. Now I'll have to show you it sort. I'll have to show you that. I can actually demonstrate it, I think, by doing that. So if I do that, let me see. I'm just going to demonstrate it sorting. So what it does, it takes an array, and I want to give it an array with 7 elements in. And as you can see, it worked. It's got the 4. In fact, it hasn't worked. It's off by 1. I've got to do an offset somewhere, because the 3 is supposed to be first. And then the 4, and then the 2. So it's offset somewhere. So what I'm going to have to do is, I'm going to have to troubleshoot the problem. If I just saw what the problem is, on our board it will not be a 0 indexed array. So if I do it as it is there, it should do 4 in the middle. And that's it. It's done 4, 3, 5, 2, 6, and then 1, 7. So that should now work. Now what I'm gonna do a little test of it. I'm not gonna play a game. I'm gonna set it to a depth of 2. I'm just gonna make it play itself. Oh man. I must have missed something. Oh man. The issue is this pre-move list. It's not initialized. It's not initialized. So what I'm gonna do is I'm gonna force it to play itself. And as you saw there, it took the center squares, because what it was doing is, before it would say all these moves have got an evaluation of 0, so all of them are the same score. So it will put 0 there. However, now what it now does is it starts here. So when it thinks that they all have the same score, it will play this move because that's the first one it started with. So that achieves the same without me altering the evaluation function. I'm able to achieve the same thing. So what I'm going to now do is I'm going to test these speed things. I'm going to test one of them. I'll test one of them and just make a note here of what the score is. But I have to pause the video because obviously it's going to use processors up and it might mess the video up. So I'm just going to pause the video while I do it. Okay, I've put them both of the positions in, and that was the results. I've put them in here, and as you can see, I'm still well off target. I'm beginning to worry now that I might not hit these targets. Okay, so that's well off. Still, that's well off. Now, the changes that I made just now, they increase the speed by 4-fold. Okay, so it's a 4-fold increase. And that was just for a few lines of code. Okay, so what I want to do now is, I think I went on earlier parts of the video. I went through some piece of code, and I remember I said that some of something like this, it's got a lot of fast operations in it, so it's going to be hard to make this faster. Because even though even though you might say, okay, if I, for instance, I'll give you an example of what I'm talking about. At the moment, to find a legal move, it comes here, then it goes blah, 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 blah. And it says, and then it says, okay, 46 is the move, and then it comes with 46, then it goes blah, 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 blah. Now you may think, okay, let's have a quicker way to do it. Let's work out the legal moves here, and then when we add a move, we add it here. For instance, the difference between these two is 9, so you just add 9 there. And then you can always say, get me the legal moves, and you always know what they are. But because these operate, because the operations are so fast, even though in theory that would seem like it would speed it up, it actually wouldn't. Because what it is, for starts, if we had a scheme like that to speed it may speed it up by 10% or 20%. But we just done something simple then, and we treble the speed. It probably wouldn't. It probably wouldn't increase it by more than 10%, because even though it seems more efficient than running down here, getting to the end and saying 56 is the legal move, then running down here, okay. The computer does that running down there so fast that if we done another method of doing it, that is in theory faster. For instance, we work out these, and then when we want to add something, for instance, say the user pressed 46. All we have to do is do 46 modular board width, and we're going to get 1. Column 1, we add 9, and we're going to get, and then we just get, and then all we do is we get the numbers in array, and then we can just get the numbers in. But the problem is, we'd have to work out modular. We'd have to do a modular operation on that. When we get 49, we'd have to do modular to get the 1. And also, every time we add, at the moment, when we make a move, this is us making a move, and that is us remaking a move. That is us removing a move, and these are extremely fast operations. So it's hard for us to, even though some things in theory seem fast, because I've actually already tried that thing what I'm talking about, and it didn't speed it up. And I've also tried this other thing that in theory was fast, but what it is, there's always some operation, like for instance, the modulus operation, the filter operation, or the sort operation. There's always some operation that slows it down. And because these operations are, for the computer to do this, it does it extremely fast. So if we change the scheme, and then when we add something to the board, we'd have to sort of change. This would have to be more complicated, and it would slow it down, and then any speed that we gain will be lost. Okay. So I'm going to end the video now, and in the next video, I'm going to do another. I'm going to use the Google Chrome tools to find where the bottleneck is, to find what is causing all the speed loss, and then I'm going to concentrate on that rather than look at theoretical things like, well, like for instance, it's really logical to say, why are we doing? But the problem is, it does it so fast that the way that you do it, that seems in theory to be faster, it will not be faster. Because for instance, for we know, the computer could loop all of these 64 squares before it does one modulus calculation. Okay. Now that's the end of the video now. Until next time, bye.